Hello, welcome to this tutorial. In this tutorial, we are looking at angle of elevation and depression and bearings. So by the end of this tutorial, we should be able to solve problems involving angle of elevation and depression, and as well as bearings related to angle of depression and elevation. So in one of our previous classes, we've discussed the concept of angle of elevation and depression. So today we look at solving problems under it. My name is Ademola Folarin. This tutorial is powered by IOTA Virtual Learning. Let's take view of this. In this, we have a person B and a person A. If the person A standing here decide to look at person B who is standing on top of a tree, he will be looking at the person B on an angle called angle of elevation. So for someone who is on the ground looking at an object above, will be looking at the object at an angle of elevation. While the person B standing above the ground on an object will be looking at the person A with an angle called angle of depression. Angle of depression. So basically, for a person A, this is a normal high level. That's the horizontal level. So should he look upward, he will be looking at an object at an angle of elevation. For the person B, looking downward, will be looking at an object at the angle of depression. So the angle between the horizontal ground and your line of sight to the top of an object is known as angle of elevation. While the angle between the horizontal line to the line of sight below the observer is called the angle of depression. So let's say, for example, in this case, we have observer here and we have object here. The same thing here. Let's say we have an observer and we have objects here. In this case, the observer maintains the horizontal ground in this manner. So should he look at this object, he will be looking at the object at an angle of elevation. For the second case, this is the horizontal ground for the observer. Should he look at the object below, we'll be looking at the object at an angle of depression. At an angle of depression. So oftentimes, when we analyze this diagram, it always ends up in a right angle triangle. So when an observer have his line of sight above the ground, is an angle of elevation. If it is observed downward, is an angle of depression. So in solving these, the three basic trigonometric ratios that we use are our sine, cosine, and tangent. And remember that sine theta is equals to opposite over hypotenuse. That is the ratio of opposite side to hypotenuse side. While cos theta will be equals to the ratio of adjacent side to hypotenuse side, and tan theta, tan of an angle, is the ratio of opposite side to adjacent side. So these three forms a fundamental when we are solving problems involving angle of elevation and depression. So let's take an example. We have here the angle of elevation of the top of a tree 39 meters away from a point on the ground is 30 degrees. Find the height. So if we are to sketch this, if this is a tree, and there is a point on the ground, if they are both on the ground, and that's a tree, and there is a point on the ground. So if we try to connect that, the angle of elevation, normally the ground level is this way, and the angle of elevation made with that point to the top of the tree is given. The angle of elevation is 30 degrees. 30 degrees. This is the point. This is the top of the tree. The tree is 39 meters away from the point. That's 39 meters. That's the distance between them. Then the question is asking us to find the height. To find the height of the tree. So to do this, this has become a right angle triangle. If we look at this, so we have the angle. We are interested in finding the opposite side while we know the adjacent side. In a situation where we have the adjacent and we are interested in finding the opposite, so which of the trig identity are we going to combine? That is tan, meaning tan theta equals opposite divided by the adjacent. Here we have tan 30 degrees equals the opposite, which is the height, divided by the adjacent, which is 39 meters. So multiplying both sides by 39, we have 39 multiplied by tan theta equals h, the height of the tree. So this will then become 39 multiplied by the value of tan theta. We can use our calculator to get that, or our four-figure table, which will give us 0.5773 equals to the height. Then when we multiply this, we have 22.51 meters being the height. Therefore, the height of this tree can be approximated to be 23 meters. Brilliant. Let's move forward, taking another look at another example. In this situation, we are looking at a question that says a woman looking out from the window of a building at a height 30 meters. Observe the angle of depression of the top of a flagpole to be 44 degrees. If the foot of the pole is 25 meters from the foot of the building and on the same horizontal ground, find the angle of depression of the foot of the pole from the woman. So in this case, we may say the building, the woman is standing, or from the window through which she's looking. Let's take it as this, and that is said to be 30 meters. And there is another flagpole in front of to which the woman is looking. So we are asked that if the foot of the pole is 25 meters from the foot of the building, this is the building and this is the pole. if they are 25 meters apart, that's what the question is saying. 25, they are 25 meters apart. So the woman maintained angle of depression. Remember that this will be the horizontal view. So for an angle of depression to the top of the flagpole, that is said to be 44 degrees. So this is 44 degrees. 4 degrees. And this can be said to be an alternate angle into this part. The alternate angle here will also be 44 degrees. Looking at it, the knowledge of alternate angle, so 44 degrees there. And it was also said that angle of depression of the foot of the pole from the woman. So there is also a connection to the foot of the pole from here down. That's what the question is asking us to find, as this angle from here down here. That's this angle. Remember, using alternate angles is the same thing as this. So let's label that as alpha. We are interested in finding the alpha, and the height of the pole h, which is similar to from this point to this point, right? Because this, if we label this from here to here, is the same thing as from here to here. So we want to find h and the alpha. To do this, now looking at this, we've been able to get something we call a right angle triangle. To find this is the opposite side and this is the adjacent side. Opposite, adjacent side. That means for question A, that will be tan alpha is equals to the opposite, which is 30 divided by the adjacent, which is 25. And that gives us tan alpha to be equals to 1.2. Alpha then becomes the tan inverse of 1.2, where alpha is 50.19 degrees. We can approximate that angle to be 50 degrees. We can approximate it to 50 degrees. So alpha here is 50 degrees. That's the angle of depression of the foot of the pole from the woman, which is the same thing as this, 50 degrees. Now the height. To get the height of this pole, which is from here to here, that means the height can be taken away from 30. What if we say from here to here, let's denote that with x, right? So the B part, the height of this, the height h of the pole will be equals to 30 meters minus the value of x, right? So we then need to get the value of x. To get the value of x, compare this triangle from here, this and this. That's a triangle. Remember, from the base here to this is similar to this and this. So this is also 25 meters. That means we have adjacent, we are interested in opposite, giving the angle 44 degrees. Hence, we are going to be using one of our trigonometric ratios that connects opposite and adjacent. Opposite, adjacent, that is tan. Hence, we say tan 44 degrees equals the opposite, which is x, divided by the adjacent, which is 25 meters. So doing so, we multiply both sides by 25. That is 25 multiplied by tan 44 degrees. That gives us x. That will be 25 multiplied by tan 44 degrees, 0.9656 equals x. And hence, x will be 24.14 degrees. That's x. So now that we know that, therefore, the height of the pole will be equals to 30 minus 24.14, which is equals to, when we subtract this from 30, we get 5.86. Then the height can be approximated into 6 meters. That is the height of the flagpole here. Isn't that interesting? Brilliant. So let's also look at a bearing question that may end up in the use of trigonometric ratio. The question reads, Q is 24 kilometers away from point P on a bearing of 042 degrees. That's 3 figure bearing. And R is 25 kilometers from point P on a bearing of 132 degrees. Calculate the bearing of R from Q. So if we are to sketch this, it is similar to saying the point P somewhere because the bearing of Q is from P. So the bearing is said to be on 42 degrees. 42 degrees. That's reading from this. 42 is somewhere here. So we can pick the bearing 42 degrees and is on 32 kilometers. So this one is 42 degrees, 32 kilometers. That's for point Q. The point Q. Alright. You can label this P. This is Q. Now, R is 25 kilometers from P on a bearing of 132 degrees. So on a bearing of 132 degrees, if we look at this, 90, so 132 is probably somewhere here on that bearing, and it is 25 kilometers. So that's somewhere here, 25 kilometers. If we have it that way, that's a point R. That's point R. We label that to be R. Then we have to join this point with point. So having it this way now, the angle P into this system PQR, the angle P will be obtained, let's say angle P, that is QPR, will be obtained by noticing that the green one here is 42 and the purple here is 132. So it means it is between this and this. That's angle P, which will be obtained by saying 132 degrees, subtract 42 from it, minus 42 degrees. That will give us angle 90 degrees. So if it is angle 90, automatically what we have here is a right angle triangle. If this is 90 degrees, then this is hypotenuse side, the longest side of a right angle triangle. Remember, this is 25 kilometers. So if this is 90, we are interested in finding the bearing of R from Q. The bearing of R from Q will follow the path this. That's the bearing of R from Q. So noticing this, it means this is 90. This is another 90, making it 180. 180 plus a small angle here. Recall that the whole of this is 42. The whole of this, that is from this point to the red here, is 42. So it means the little angle we are interested in will be between this and this. That is subtracting this angle from 42. If we take this angle from 42, this angle now, let's denote it as alpha. That's angle Q. So we must first be able to explain that the bearing of R from Q equals 180 degrees plus then this angle alpha taken away from 42, open bracket, 42 degrees minus alpha. So that will be the bearing. And to do this, we need to calculate the value of alpha. Since this is a right angle triangle, the value of alpha will be opposite to adjacent. That means the alpha opposite to adjacent, which is tan alpha equals opposite 25 divided by 32. So tan alpha will be equals to 0.7812. Then alpha will be equals to, we take the tan inverse of this value, tan inverse of 0.7812, which will be 37.99. That means the alpha can be approximated into 38 degrees. Now we know the value of alpha to be 38 degrees. So the bearing of R from this will be equals to 180 degrees plus, open bracket, 42 degrees minus 38 degrees, close the bracket, equals 180 degrees plus, so when we subtract this, what do we have? We have 4 degrees. Adding this together, the bearing of R from Q will be 184 degrees. So That is this on the problem involving angle of elevation and depression. So don't forget to drop your comments, your question, or your observation. Till we come your way next time, keep learning mathematics. Thank you very much.